Codex is a software engineering agent, an agent that lives in the cloud and fixes your bugs, reviews your code, and slaps duct tape on your spaghetti functions, all powered by OpenAI's mighty O3 brain, fine-tuned for real-world code carnage. 2 ways to summon Codex. Ask mode, for when you need wisdom. Why does my architecture look like IKEA instructions? Code mode, for when you want actual changes, tests, bug fixes, even pull requests like magic scrolls. Once launched, Codex runs terminal commands in a loop like a caffeinated squirrel. It reads your agents.md file, if it exists, and honors your setup, tests, and style guides. It doesn't know everything, but it tries real hard, and that's worth something, right? What you can ask it to do? You can make Codex. Refactor your code so it stops crying at night. Review diffs like a caffeinated CTO. Add missing tests. You were gonna do it, weren't you? Find bugs based on stack traces. Fix UI issues even without seeing your browser. Codex just feels the vibes.
You can tune Codex's container with setup scripts, environment variables, and even encrypted secrets. Want Python 3.11 and PNPM? You got it. Want it to respect your linter like it's holy scripture? Add it to agents.md. Codex don't get free reign on the web. During setup, it can download packages, but once it's working, it's sandbox tighter than grandma's cookie jar. You can toggle access, sure, but make sure it goes through the blessed proxy and trust that fancy Codex proxy cert.
Security's no joke. Codex needs multi-factor auth to enter your repo playground. If you log in with email plus password, you must turn on MFA. Google, Apple, Microsoft, still a good idea. We like our engineers verified and our containers secure. Codex is here to take the grunt work off your plate. Fewer bugs, cleaner code, more brain power for the stuff you actually care about. Just head to chat.openai.com/codex, plug in your repo, and start delegating. Oh, and don't forget to say thank you. Even AI agents like a little appreciation.
Ever wonder what happens after you type a prompt into Codex? Let's pull back the curtain and explore the wizardry behind the scenes. Origin and philosophy. OpenAI's research paper, Evaluating Large Language Models Trained on Code, introduced Codex in 2021 as a GPT-3 descendant specialized in code synthesis. It solved 28.8% of human eval problems in one shot and up to 70% with sampling, demonstrating the leap that domain-specific fine-tuning can give over a general LLM. Archive.org. The 2025 relaunch, Codex-1, ports that idea onto the newer O3 backbone and wraps it in a full agent workflow so developers can delegate entire tickets, not just prompts. Training data and tricks. How the kid learned. Millions of GitHub projects. It read permissively licensed repos line by line, Python, JS, Rust, you name it, so it could imitate good style. Practice with quizzes. Engineers let Codex fix real tickets and rewarded it when tests passed, a fancy version of good dog, have a treat. Huge memory. With a 192K token window, it can keep whole code bases in its head instead of forgetting file 27. Agent workflow. What happens after you hit enter? You give a prompt. Codex spins up a fresh cloud computer, the universal container, and clones your repo. Ask mode, read only, great for Q&A. Code mode, full toolbox, edits code, runs tests, returns a Git diff. Agents.md acts like a to-do list, telling it which linter to run and which folders are off limits. Safety, isolation, and MFA. Bubble wrap and padlocks. Each task runs in a sealed box. Internet is off unless you flip the switch, and even then, traffic goes through a monitored proxy. Because Codex can push code to prod, OpenAI makes you enable MFA first, no exceptions for email and password logins. Performance benchmarks. Human eval. Scores jump from 28% old GPT-3 to 70% when Codex can sample multiple answers. SWE bench and internal tasks. Codex lands near the top of real bug fix leaderboards and already drafts PRs inside OpenAI repos. Limitations and risks exist, as even geniuses can spill coffee. Codex can hallucinate APIs, miss edge cases, or add subtle security bugs, so code review is still necessary. Licensing and data leak concerns persist. OpenAI is publishing system cards and conducting red team audits to address these gaps. The future looks promising. The roadmap includes larger context windows, IDE plugins, optional internet queries, and a tighter integration with static analysis tools to ensure the safety of fixes before shipping. A competitive race is underway, with Google's Gemini and Anthropic's Claude pursuing similar agent technology. This competition will drive rapid improvements.
Hey, what's up guys? Jake here, and today we're cracking open OpenAI's Codex to see what's really going on behind the scenes. We'll look at how Codex spins up sandbox containers, runs your tests, and spits out a PR diff, all before you finish your coffee. First question from the comments. Bro, is this just ChatGPT with extra RAM?
Nope. Codex runs Codex 1, a version of the O3 model fine-tuned on billions of code tokens. It doesn't just autocomplete, it edits, tests, and commits inside a container all by itself. That jumbo 192K context means it can keep dozens of files in memory. Goodbye file-by-file amnesia.
Viewer at DevDonnie asks, which button do I press?
Well, hit Ask mode if you want audits, diagrams, or architecture advice. Codex clones a read-only repo and answers like a super senior dev. Hit Code mode when you want real edits. Codex gets write access, loops, edit, run tests, replan, then hands you a Git diff to review.
My project needs pip install from GitHub. Codex can't reach it.
First things first, Codex containers lose internet the moment the agent phase starts, so any pip install git plus https:/github.com command that runs after setup will 404. Use the 90-second setup script window. During setup.sh, the container still has outbound access, which means you can run this code. Because that runs before the network shutoff, it sails through. Tip: add the command plus a note to rerun tests in agents.md so the agent always respects it.
I haven't really tried it, but is it just a worse Cursor or Trae or something different?
Codex isn't a worse Cursor or another Trae. All three products sit in the AI coding toolbox, but they solve different problems in different places. OpenAI Codex, a cloud-hosted agent that spins up a fresh container, clones your repo, runs tests/linsers, and sends back a ready-to-merge Git diff. It excels at whole repo refactors and multi-step bug fixes. Cursor, a VS Code-based IDE fork with inline completions and a chat pane. It's lightning fast for fill in this function or explain this snippet, but it never leaves your editor and can't run your test suite end-to-end. Trae, a free standalone editor, also VS Code flavored, that leans into configurable agents for end-to-end full-stack scaffolding and multimodal inputs, images, voice. Think BuilderBot for Greenfield apps. Cursor completes in seconds because it's powered by live prompt completions, great for micro-edits. Codex takes 3 to 8 minutes, sometimes up to 30, because it installs deps, runs tests, and iterates until they pass, trading latency for higher confidence. Trae sits in the middle, fast chat completions for tweaks, but builder tasks, full app scaffolds, run longer, similar to Codex's container cycle. Codex. Use it when You need a multi-file refactor, security audit, or test autogen that must pass CI before merge. You're fine with a short coffee break while the agent churns. You want reproducible logs/diffs for code review. Cursor, use it when you want inline autocomplete and chat right in VS Code. Tasks are bite-sized and don't require spinning a container. You already know the fix and just need a smart copilot to type faster. Trae, use it when 1. You're starting a greenfield app and want one prompt scaffolding, DB, API, front-end. 2. You like tinkering with custom agents and multimodal context. Paste Figma screenshot, generate code. And finally, you're price-sensitive. Trae's free tier is generous.
Johnny Davidson says, I'm failing to see how I would test the changes made by this. Answering questions about the codebase is great, but making actual changes?
I understand your concern. Testing changes made by Codex or any automated tool can be challenging, especially in codebases lacking existing tests. Here's how you can approach this. Start with high-level integration tests. In untested codebases, writing unit tests can be daunting due to tight coupling and lack of modularity. Instead, begin with integration tests that cover the main functionalities of your application. Implement characterization tests. Characterization tests, also known as golden master tests, help you understand and lock down the current behavior of your code. This is especially useful when the existing behavior is not well documented. Leverage approval testing. Approval testing is a technique where you capture the output of your application and compare it against a known good output. This is particularly useful when the output is complex or difficult to assert against. Integrate tests into continuous integration, CI. Once you have a suite of tests, integrate them into your CI pipeline. This ensures that any changes, whether manual or automated, are automatically tested. Gradually refactor and add unit tests. As you become more confident with the existing codebase, start refactoring parts of the code to make them more testable. Add unit tests for these refactored components to ensure their correctness.
Reddit's verdict so far, Codex is the smartest junior dev money can't buy yet. It shines on multi-file refactors and automated test runs, but its sandbox fences and slower cycle times mean it won't replace your IDE autocomplete just yet. Keep your review goggles on and happy delegating. That's it for today, guys. Until the next one.